Here we have our last example for the quotient rule. As we look at this problem, note that it's already written in the first derivative form, and so we're actually looking for a second derivative. As I look at the problem, I do see a fraction here which most generally would set up or indicate the idea that we want to use a quotient rule. But for this particular problem, I'm actually going to work it through using the product rule. And how I do that is I'm going to rewrite the problem as 3x squared times the quantity 4 minus x minus 2 raised to the negative first. Essentially, I'm bringing this up and then I can use it as a power idea and then do a product with the power. And so for the first step, notice my notation. I go from the first derivative to notation for the second derivative. And I'm going to use the product rule. So I have a u and a v. So I do u dv. dv comes from me going the derivative of this. Negative 1 times negative 1 is positive 1 x minus 2 to the negative second. Plus v, so I write all this, times du, derivative of 3x squared is 6x. And then for my next step, I take this negative exponent, I drop it down, turning this first term into a fraction. I distribute the 6x across this set of parentheses, so this becomes 24x, minus 6x over x minus 2, because that negative exponent drops that down. And so I have three terms here. As I look at the three terms, I decide to go for a common denominator. So the first term is already good. The second term is 24x. I needed to multiply the top and the bottom by x minus 2 quantity squared. In my numerator, please note that I already expanded the x minus 2 quantity squared into x squared minus 4x plus 4. And then for this third term, all I needed to do was multiply the top and the bottom by x minus 2. On my next line, I simply expanded what I had. So this 3x squared, I wrote down here. I distributed the 24x across this trinomial, giving me 24x cubed minus 96x squared plus 96x. And then I distributed this negative 6x across the binomial, creating negative 6x squared and positive 12x, all over the common denominator of x minus 2 quantity squared. My last step would then be to write these in descending order and combine my like terms. As I combine those like terms and write these in descending order, I get 24x cubed. I look at all these x squared terms, and that gives me negative 99x squared. And then just the regular x terms give me the 96x plus the 102x, 108x, all over x minus 2 quantity squared. And there's our last example for the quotient rule.